This is the third question of JEE Advanced 2025 paper 1. So in this question it is given that there is a conducting square loop initially lies in xz plane. So it is like this, and with its lower edge hinged about x-axis, only region y is greater than 0. Okay, so y is greater than 0, there is a time dependent magnetic field pointing about the z direction. Okay, so about the z direction, there is a magnetic field and that is in this region only. Okay, in this region there is no magnetic field in the negative y direction. Okay, then the magnetic field is given like this: bt equals to b naught cos omega t. B naught is constant, magnetic field is 0 everywhere else. At time t equals to 0, loop starts rotating with constant angular velocity omega about x-axis in clockwise direction viewed from positive x-axis as on the figure. Ignoring self-induction in the loop and the gravity, which of the following plots correctly a representation of induced EMF in the loop as function of time? Okay, so we need to calculate induced EMF in that loop. So for that, I have taken it like this. The magnetic field is like this. So flux is defined like this: B vector dot A vector. So it becomes B is a magnetic field on dependent on time. So that's why function BT times of A, and let's suppose this angle is theta and the magnetic field is like this. So the area perpendicular to this is going to be A sine theta. So that's why it is BT times of A sine theta. So BT is B naught cos omega t, and A and sine theta, because we are rotating like this, so that's why it becomes omega t. So we get the flux is A B naught, and then we can write down this as sine theta cos theta, so that is sine 2 theta divided by 2. So we get AB naught divided by 2 and sine 2 theta. Sine 2 theta differentiation, because we want to calculate EMF, and EMF magnitude is d phi by dt. So that becomes AB naught divided by 2. This is just the same constant, and sine 2 theta differentiation is the 2 omega in front and then the cos 2 omega t, right? So then from there we get that the this value becomes AB naught omega and times of cos 2 omega t. Okay, so all right, when we are rotating and we are starting at t equals to 0, this loop will be here at t equals to pi by omega, right? Okay, so t will at t equals to pi by omega. Let us find out what is the EMF value at t equals to 0. So at t equals to 0, we have the maximum value of EMF, this magnitude AB naught omega, because cos 0 is 1. And when we place here, then E will be equals to, at t equals to pi by omega, we'll get AB naught omega times of cos 2 omega times of pi by omega. So basically 2 pi, which is again 1. So we'll get EMF equals to AB naught omega times of 1. Okay, so it means the EMF is completing one complete cycle in the half cycle of the rotation. Okay, EMF is completing a complete cycle in half cycle of rotation. So if you look at the options, they have given all the options. First of all, these options are incorrect because they are starting at t equals to 0. They are saying that the EMF is 0. Now I have either this option and this option. So in this option, if I look, it is completing a half cycle in a time period of 2 pi by omega, which is incorrect. Okay, because in the time period of pi by omega itself, this EMF is completing a complete cycle, because here we get 2 pi. Okay, and after that, if we look, because there is no magnetic field, so although we rotate here, there will not be any EMF, so there should be 0 EMF as well in the graph. So from that I can say option A should be correct.